question 4. So we're moving along quite quickly. We've got this line here, L1, and we have another line, L2. And the question is asking us, are the lines L1 and L2 parallel, perpendicular, or neither? So we've got to understand what it means by parallel. Well, parallel, that means M is going to be the same, right? So if this gradient is 5, for example, this gradient must also be 5. If they're both the same, the lines are going to be parallel with each other. If they're perpendicular, what it means is that if this gradient here was 3, for example, then this one must be minus a third. It's a negative reciprocal. And if it's neither, clearly it doesn't satisfy parallel or perpendicular. So what we're going to do is we're going to get the gradient of both the lines, and then we can check whether it's parallel, perpendicular, or neither. So let's deal with L1 first. So L1. Well, a 4y minus 3x equals 10. Well, remember, we want this form, y equals, and you've probably heard it a million times from GCSE and such, y equals mx plus c, right? That's the key bit here. We want y equals mx plus c. Well, at the minute, it's 4y minus 3x equals 10. So what I'm going to do is take the 3x onto that side. So now I've got 4y, and let's go from there. So we've got 4y equals, take your 3x across, it's going to be positive 3x plus 10. Now, remember it's got to be in the form y equals, so we're going to have to divide through by 4, because we need this coefficient here to be 1. So to get rid of the 4, divide through by 4. So this gives me y equals, well, if I divide everything by 4, I'm going to get 3 over 4 here. Oh, dear. That should be, let me rub that out. So this is going to be a 3 over 4 here. 3 over 4x. And then if I divide the 10 by 4, that's the same as 5 over 2. I'll just simplify it straight away. Plus 5 over 2. But the 5 over 2 is irrelevant. We only care about the gradients. So, if L2 and L1 are parallel, well, what that means is that L2 either has to have a gradient of 3 over 4. That would mean they're parallel. It either needs to be minus 4 over 3 to be perpendicular, or if it's something totally different, then it's neither. So let's check what L2 is. So that was L1. L2, let's check. We've got these points here, 5 minus 1 and minus 1, 8. So you've got to think about what you can do to get the gradient of this. So remember, the gradient, m, is going to be equal to y2 minus y1 all divided by x2 minus x1. That's going to give me the gradient. Now y2 is just one of your y coordinates, y1 being the other, and same with your x2 and x1. So if I call this one y2, the 8, then this one is my y1. And same here, this has to be x2 if this is y2. So let's use this as y2, 8. So this gives me m equals 8 for the y2 minus, so minus 1. Now be very careful with your signs. Obviously you've got your calculators, just make sure you put it on your calculators, correctly. 8 minus 1, so that's going to give me 9. And then the denominator is going to be minus 1 minus 5. That's my x1 coordinate here, minus 5. So minus 1 minus 5 is going to give me minus 6. So let's cancel that down. What have we got? So that's going to be minus 3 over 2, like that. So that's my gradient here. That's my m for L2. Well, the issue here is that this is not parallel to this. 3 over 4 is not the same as minus 3 over 2, obviously. This isn't the perpendicular, or they can't be perpendicular because this isn't the negative reciprocal either. If it was minus 4 over 3, then yeah, we'd have a perpendicular set of lines. But because this is minus 3 over 2, they are not parallel, they are not perpendicular, they are neither. And there you go, that's your 4 marks for that question, guys.